All right. Nice to see everybody. This is Predicting the Future of Web Development. I'm Richard Feldman. So I want to start off with a question. How many people here have ever gotten to choose your stack at work? Like you got a greenfield project, there's no technology yet, nothing's been built yet, and you get to kind of choose or participate in the choosing of what technology stack you're going to use. Okay, yeah, quite a few people. So I was in this position once. Actually, the first time I was in this position, the first web application that I ever worked on, this was back in 2006. And I don't know if anyone else has been doing web development back then, but at the time, if you were building a web app, really the most popular way to do this was what was called the LAMP stack. And this stood for Linux, Apache, MySQL, and then the P was kind of overloaded to like PHP and Perl and Python, and then Ruby on Rails kind of came in like 2005 and sort of got even more overloaded. So back in 2006, we had this choice where it was a startup. There were 4 of us. None of us had ever built a web app before, and so we were kind of trying to figure out what should our tech stack be. And there's this philosophy of choosing tech stacks that goes choose boring technology, like choose stuff that's just kind of mainstream and everybody knows it's a known quantity. You know, kind of just go with the flow, do what everybody else is doing. So back in 2006, here's an example of a boring technology, and actually this is the one that we ended up going with. It had the #1 biggest library ecosystem of the entire LAMP stack. It was the most mature by pretty considerable margin. It was battle tested. It was used by successful companies, including the social networking giant of the day, which was LiveJournal. And so this is the methodology by which we ended up betting our entire startup on Perl. Biggest library ecosystem, most mature, used by successful companies. This decision didn't age super well. So this is the Google Trends search for Perl since 2006. There's a slight decline in interest, you might say. And so if we had actually, that company ended up going out of business, as many startups do, but if that company were still around today, this would have turned out really poorly for us. It would be really difficult for us to be trying to hire Perl developers because a lot of people have lost interest in the technology. And so basically, if we had made that decision and then stuck with it and still been stuck with it today, there's a pretty good chance we'd be saying, you know what, we got to rewrite. We can't be on Perl anymore. It's just too much of a liability. So the moral of this story is that choose boring technology is not a recipe for success. It doesn't guarantee that you're going to get a good outcome. In fact, anytime you choose any technology, we're making a bet. We have to be making a bet. And what we're really hoping is that the choice that we make today is still going to be a choice that we're happy with like 5 to 10 years from now. And no matter how popular, how mainstream, even if it's #1, so think about whatever technology you think of as right now, that's the most popular thing. That's the #1 thing. That's what everyone's using, the biggest ecosystem. 5 to 10 years from now, it might end up being something that you regret. So the real question here is not so much what's the most popular, but what is something that we think will age well. So I would say if we're going to be looking at what's going to age well and what will we be happy we chose, 5+ years from now, I think predicting the future, like trying to make predictions about what's going to be something that lasts is a lot better than just kind of following blindly whatever the current trends are. So even though predicting, let's be honest, doesn't often age well, like we make predictions and then we look back at them 5 years from now and we say, that was totally off. Still, it's better than the alternative. It's better than sort of random guessing. So I'm going to be making some predictions today, at my own risk of looking foolish later, because I think that's really what we have to do if we want to get the best outcome. So I'm going to be specifically making some predictions about things that I think will be true by the end of 2020, and then also some things I think will be true a little bit longer term by the end of 2025. I'm going to break these down into 4 areas. So first I'm going to talk about TypeScript, then WebAssembly, packages, and finally compile-to-JS languages. All right, so let's start with TypeScript. More like HypeScript, am I right? Oh man, everybody's talking about this thing. I realize that at this point I don't even need to bother explaining what TypeScript is because so many people have heard of it. This is the Google Trends searches for TypeScript. It's almost the opposite of the Perl graph. I mean, it's just been shooting up and up. One question I've heard people ask is okay, yeah, but we've seen compile-to-JS languages get really popular and then taper off, like CoffeeScript. CoffeeScript got really big. At one point, it was the 11th most popular language on GitHub, but then it really tapered off and no longer is considered the next big thing. So a question people ask is TypeScript going to be the same thing? Is it all hype, or is there substance there too? Is it actually going to last? Well, I think one thing that's kind of instructive is to look at like what do the trends look like comparing TypeScript and CoffeeScript. So this is CoffeeScript sort of overlaid on the same graph of TypeScript in terms of, and again, this is just search terms, so this is kind of a representation of maybe interest more than anything. We can see that even when CoffeeScript peaked, it was nowhere near the interest level that TypeScript has gotten today. And granted, you do have to take that with a grain of salt, which is that the number of front-end developers is also increasing year after year. So naturally, something that looks popular today is going to be a lot bigger in terms of raw numbers than something that looked popular back in like 2011 when CoffeeScript was really big. But another point to look at is just that like TypeScript's trend is just nowhere, showing no signs of slowing down. So I think at a bare minimum, it would be really premature to say, yeah, TypeScript probably going to be like CoffeeScript. If anything, it looks like the trend is that it's going to continue growing. Another thing to look at is that there's a massive adoption of TypeScript among like all of the most popular libraries in the JavaScript world. Like you can't really throw a rock without hitting a framework that's either already got first-class TypeScript support or is working on adding it. Even stuff from companies that have competing things like React, you can find very easy first-class like TypeScript definitions, despite the fact that React comes from Facebook and Facebook has a competing alternative to TypeScript called Flow. Polymer, same thing, comes from Google. Actually, Google had the first compile-to-JS type checker in the Google Closure compiler, and yet the Polymer team is working on adding first-class TypeScript support. This was not true of CoffeeScript. Like this is a very different thing that we're seeing now in terms of libraries and frameworks getting on board than we did with CoffeeScript. Okay, so what's not to like about it? I mean, there's a bunch of people who are obviously adopting it and getting behind it, but there are also people who don't like it, and they have some pretty valid reasons. I saw this one on Twitter. This was something that someone tweeted. They were complaining about this type. I'm going to read this out loud. This is component class bracket pick bracket route component props bracket any comma static context comma any close bracket never close bracket any close bracket and with router statics bracket parentheses props colon props with children bracket route component props bracket any static context any close paren arrow element. That was one type. So the person was complaining about this, and I can't help but read this type and think back like all the Java people, in the house. Which, I was a Java programmer for earlier part of my career, and like looking back, like you all made fun of us with our abstract singleton factory proxy bean. Well, who's laughing now? I mean, this is this is like I could say that in one breath. And David Nolan at a previous conference I was at, he commented that maybe TypeScript is like enterprise JavaScript. And I think there's some truth to that. So one other thing that people dislike about TypeScript is the fact that although it's giving you a lot more type checking than you have in JavaScript, which of course it's right there in the name, that's kind of what people come to TypeScript for. At the end of the day, it's not really completely safe because TypeScript's type system is by design unsound. So they have this thing called any, and basically anytime you see the any type, that means actually this is not type checked and anything goes and this might blow up later. Really can't make any guarantees about it. And the any appears 4 times in this one type alone. Something that's kind of all over the ecosystem. So there's a lot of people saying like, yeah, okay, we're doing all this work, we're getting these really verbose types in a lot of cases, but we're still not getting like actual safety. We're getting like kind of mostly safety. It's like better than before, but it's not really all the way there. So there's various things not to like about it, but at the end of the day, I think the most compelling reason to think that TypeScript is going to keep growing is the impact that it has on teams and the dynamic that they have. I hear a lot of teams saying, we're switching to TypeScript, or we have switched to TypeScript, or we've been using TypeScript, or we're thinking about switching to TypeScript. And once they do, I hear almost no teams say, we're switching back from TypeScript. We decided after using it that we're going to go back to JavaScript. I really don't hear that happening. Actually, I've never heard that happening. I just, for the sake of argument, I'm going to say almost never. but literally, I have never personally heard of a single team that switched to TypeScript and then later went back to JavaScript. It's conceivable that they're out there. But when you hear a dynamic like that, I mean, TypeScript is basically a ratchet. I mean, it's something that people switch to and then they don't switch back. They switch and then they switch. Even if 1 or 2 individuals on the team don't like it, if the whole team never goes back, that's a recipe for it continuing to grow for a really long time. There's a tweet that kind of embodies this. If you're the one person on the team who doesn't like it, at the end of the day, I mean, maybe you're not happy about it, but that's still what everybody else is doing, and you're still kind of, yeah, it's pretty good. Yeah, like regardless of your personal feelings about it, if everybody else around you is going with it, that's just what's going to end up getting adopted. So this is my first prediction. I think TypeScript is going to take over the JavaScript world in a way that we've never seen before in the history of JavaScript. So I think by the end of 2020, it's going to be the most common choice for commercial, like new JavaScript projects. So if I work for a company and that company does JavaScript, which as it happens I don't, but if I did, and we were looking for a new project, I predict that most companies in that position, teams are going to pick TypeScript instead of JavaScript for that new project, most of them, by the end of 2020. And by 2025, I actually think on a daily basis, there will be more people writing TypeScript in the world than writing JavaScript without TypeScript. So that's what I mean by really like taking over the world. That's never been true of any JavaScript dialect in the history of JavaScript, but I think TypeScript is going to be the first one to do it. And I think they'll do it by the end of 2025. We'll find out. All right, so that's the first prediction. Let's move on to part 2, WebAssembly. So I really cannot do justice to an introduction to WebAssembly in the way that Lynn Clark can. She's just one of the great explainers of our time. So I highly recommend looking at her introductions to WebAssembly to get a really deep understanding of what it is. So for the purposes of this talk, since it's one of the 4 things I'm going to be talking about, I'm just going to vastly oversimplify it and say that basically WebAssembly is a way to run almost machine code in the browser. And the upshot of this is that it means that we can run applications that run a lot faster than JavaScript. Machine code is just a lot faster than having to have a whole virtual machine and things like that. So what can we do with something that runs much faster than JavaScript? Well, one answer is we could say we could improve the performance of existing JavaScript apps and libraries. So one of the use cases Lynn brings up is, let's say you've got React.js. One of the steps that it does this reconciliation between the virtual DOM and the real DOM. We could speed that up if the team making React replaced the JavaScript code that does that with WebAssembly code. That could be a lot higher performance, and users of React wouldn't necessarily need to know. I think that's a potentially viable thing, but I actually don't think that's nearly the biggest way in which I think WebAssembly will ultimately have an impact. And the reason that I think this is in large part that I think that existing JavaScript performance is pretty much widely accepted as okay. And I base this on experience. So I'm on the Elm Core Team, and a couple of years ago we had this release where we're like, wow, look, we made the Elm rendering system much faster. Check it out. We had these great graphs of comparing Elm and React and Angular and Ember and all these different things. It's like, look, Elm is like the fastest. It's got the best rendering now. Isn't that great? And everybody was like, okay, good job. I mean, but React is fine, so we're going to keep using that. It's just not really a big selling point. I think maybe there was a time, maybe pre-2008 when JavaScript was super slow, and then the V8 came along and JavaScript got a lot faster. And ever since then, everybody's been pretty much yeah, it's fine. I mean, it's whatever is the fastest thing is not really the selling point that it once was. So the fact that WebAssembly would let us go even faster, I don't know that that's a thing that people really care about these days in practice. The more compelling use case, I think, is a company like Figma. So anyone here heard of Figma? Oh, quite a few people. OK. So Figma makes graphics editing software, and they make it in the browser. So this is a screenshot of their app. This is basically like a Photoshop or Illustrator competitor, or Sketch. So you do all your editing in the browser. You get nice things like, you can start using it right away. You don't have to download and install it. You get to link things right there in the browser. You got your back button, all the various things that we're used to with the browser. When you come to use it, you're always using the latest version. You don't have to do a separate out-of-band update process. This whole UI, their whole application, is not written using traditional web technologies as we think of them. This is all written in C++, but it's delivered in the browser. And this is something that WebAssembly makes not only possible, but because it's been possible through various kind of hackier ways in the past, but it makes it a lot better. So Figma actually wrote a whole blog post about what a big deal WebAssembly was for them. It was like a 3x performance improvement for their C++ compiling to the browser. So a reasonable question to ask is okay, so is this the future? If companies are writing C++ to build their applications that can go much faster than HTML, CSS, and JavaScript, does that mean that they're just doing something fundamentally different and that's what everyone's going to be doing? I don't think that's quite it. I think it's more that what they're doing is basically they're building a native application that's just distributed through the browser. I mean, if they weren't distributing this application through the browser, they'd still be writing it in C++. It's just they'd be shipping it as a desktop client. They'd be saying, download and install this the same way you would as Photoshop, distributing it through an app store, something like that. But they've chosen to distribute it through the browser because that's actually a viable thing you can do in this day and age, which was not true in 2006, back when I was doing my first web app. If you wanted to do this project, you just couldn't. The browser engines were not fast enough and good enough at running things like this. But now it is possible, and so Figma can base their whole business on this. Now, another point to make here is that this is actually something that browsers can now compete with app stores and installers where they really couldn't before. If you wanted to say, I want to ship this app through the browser, you pretty much couldn't. But now that you can, this is sort of like a new expansion of the definition of what a web app can be. It can be this sort of native app that's basically, in all other ways, like a native app, except that it's distributed through the browser and gets to take advantage of all those nice things, like being able to use it right away. It's always up to date, et cetera. One other thing that people comment on when they hear about this is like, oh, wait a minute, like you're talking about building a C++ app. Like those are really heavyweight. Like we've got this JavaScript bloat crisis already. Are we going to be dealing with like multi-megabyte downloads for apps like this? I mean, you know, for native apps, that's totally normal. You might even hear of like multi-gigabyte downloads depending on the app. But for web apps, that's ridiculous. You can't have like multi-megabyte, you know, JavaScript. Like that's something shameworthy. Is this going to become a normal thing? Maybe. I mean, this is another thing that we learned on the Elm Core team is that large download sizes, even in the JavaScript world, are widely tolerated. I mean, people make a lot of noise about saying like, this is not how things should be, we got to change. But at the end of the day, I mean, developers follow their incentives, right? I mean, we have a boss, we have a PM who's saying like, you got to ship this thing by this date. And if it's you know big, maybe it's like, well, it'd be nice if you made it smaller. But depending on your business, in a lot of cases, it's like, yeah, that's just not going to move the needle as much as working on another feature. So this is also something we've encountered in the Elm community. So the most recent major release of Elm had this great thing where the bundle sizes just got a lot smaller for free for everyone. So we had this real-world app that demonstrated this really well. So the real-world app is kind of like a to-do MVC, but bigger. It's like a whole single-page app. And so they've got a React implementation, an Angular, Vue, and I made the Elm one. And basically, after this release, the entire application, this is like 4,000 lines of code, this single-page app, that's kind of like a medium clone, the entire bundle size of the whole app was 29 kilobytes gzipped. Whereas by contrast, like just React, no application code at all, is like 35K. So we were really proud of this. We're like, wow, this is amazing. Look how small this is. And again, everybody was like, yeah, good job. I mean, okay, yeah, that's neat. That's cool. I mean, you got a cool graph, great. But at the end of the day, right? I mean, that's just not that. Like, neither runtime performance nor download sizes are things that people in practice really seem to care a lot about in the world of the web. We talk about it a lot, and you know, maybe we make decisions on like what to try next based on that. But at the end of the day, it's just not a thing that people are saying like, you know what, I'm going to base my next tech stack decision on that. So I don't think that cost of WebAssembly is going to be a big deal in the same way that the benefit of its speed is going to be a big deal, at least for the realm of like web applications that we're doing. So another reasonable question is like, okay, so here's another possible thing that could be the future. What if like everybody just gets on board this train? They're like, hey, why not just do like a native application distributed in the browser? Why not just write C++? Everyone loves C++, right? Yeah, I don't think that's going to be the end of HTML, CSS, and JavaScript, right? I mean, there's just too many people who use this stack and where it works really well for their businesses. I don't see people saying, oh, I'm going to jump on board the WebAssembly train and drop all my HTML and CSS and JavaScript just because I can now. I don't see that happening because there's too much momentum behind this existing stack. You know, some other thing that people say is like, well, now you can run Python in the browser. Now you can run Go in the browser. You can run C# in the browser. I think maybe some people will. Like I know like a lot of people like to do C# for kind of like everything across the stack. So maybe there will be more people coming into the web application sphere using C#, but I don't think there's going to be a whole lot of teams who are sort of jumping ship from what they know and have been successful using to something else where it's like, well, the upside is it's faster and the downside is maybe it's a little bit bigger to download. I don't think that's going to be enough. I think people are going to go with familiarity and ergonomics over that. So overall, the theme here is that I think WebAssembly is going to make the web app pie get bigger. There's going to be more people doing what we consider to be web application development. It's just that our definition of web application is going to get bigger. It's going to encompass these sort of native apps distributed through the browser that right now is just like a very obscure thing. I think that's going to become less obscure and more common. One really great example of this is games. Games distributed through the browser. Like imagine trying to render this thing where a user can walk around in this 3D scene in CSS. It's not really happening. That's really not what CSS is like at all remotely capable of doing. But if you're building like a, not even a AAA game, just like a robust, like competitive 3D game, you can do that with WebAssembly today, with WebGL today and JavaScript. But I think it's going to be a lot more popular when you can do it with WebAssembly and C++ and Rust and things like that. Because at the end of the day, games are extremely performance limited. If your game runs too slowly, it's just not fun, and fun is the entire value proposition of games. So they're much more concerned with performance than, let's say, your typical web app. So I see this being an increasingly large part of like what we come to view as web applications, is games running in the browser on WebAssembly. Okay, so prediction number 2. WebAssembly expands the web app pie. To be honest, I think by the end of 2020, it's not going to make a significant difference. There's not going to be a whole ton of WebAssembly apps out there. I do think there's probably going to be people starting projects in 2020, like Figma, like games in the browser. But I don't think we're going to see enough of them for it to feel like a meaningful difference yet. But I do think by the end of 2025, there will be this new niche of sort of heavyweight web apps that are native apps distributed in the browser. And that's going to be something that we have never seen before either. All right, part 3, packages. How many people here recognize this logo? Okay, wow, I think it's like the smallest number of any of the 3 audience polls so far. This is Bower. This is a package manager that used to coexist with NPM. They were kind of competitors. They had a different approach. It was based on like going through like Git URLs, but it ended up sort of losing out to NPM. NPM has sort of taken over the JavaScript world. So given that happened, there was a reasonable question of like, is NPM the future? Like, NPM is certainly the present of the JavaScript package ecosystem, but like, is there going to become a time where people have moved on from NPM the same way that they did Bower? How many people recognize this logo? Crickets. Nobody. Okay, so this is Entropic. And basically, if you want an introduction to this, there was a talk in 2019 CJ Silverio gave called The Economics of Open Source. I highly encourage taking a look at this talk. It's a really interesting topic. And she gave this at JSConf EU. And this is where she introduced Entropic. And basically, this is a bunch of former NPM employees getting together and saying, we want to build a distributed package manager that's an alternative to NPM. And it's not just JavaScript focused. It's for all sorts of things. But basically, they're trying to build some alternative that doesn't have this centralization feature where it's like one company or one organization like controlling all the hardware. Which is kind of interesting. If you look at like Yarn, for example. So this is an example of where we've had NPM the infrastructure, like all the servers and everything, but we had a different client coming out, a competing client. We've also recently, in the past year, seen GitHub announce their like intent to make a package registry. So this is basically like the same client, and actually on GitHub's package registry website, they show using the normal NPM client, but pointing the registry at GitHub's registry instead of NPM's. So this is same client, same CLI, but different hardware. So we've seen a few different approaches to sort of making the existing NPM infrastructure either different on the front or on the back, or maybe even on both, while still maintaining the same sort of package ecosystem. This is sort of different than what Entropic is doing, where they're trying to say, let's make a new ecosystem that's fundamentally different. I think the network effects of NPM are really, really strong. And this is kind of the most important part to recognize about NPM, regardless of what people are using for the CLI and regardless of what people are using for the infrastructure. What I mean by network effects are essentially the contents of the package.json file, all the dependencies, and saying like this package depends on version this of this package, which in turn depends on version this of this package, like that whole network of packages. That's a really time-consuming thing for a community to rebuild from scratch on a different setup, which I think is a large part of the reason that sort of Bower didn't end up lasting. People built this on NPM, and that became the dominant thing. Now that it is the dominant thing, I think it's going to be really, really hard for an alternative to take over. We've also seen a couple of things that make people skeptical that maybe NPM is going to last, because it might just fall down in one of these catastrophes, one of these big press nightmares. So LeftPad, how many people remember the LeftPad incident? Yeah, so for those who didn't, this is basically someone unpublished a package that was very widely used and broke a lot of the internet. It was a pretty unfortunate day for a lot of people. There was another one, EventStream. This was a malicious package. This also happened pretty recently. So EventStream was basically where someone wanted to steal some bitcoins, and the attack vector they decided to use was getting access to someone else's popular package that was being used by their target, and publishing a malicious release of that package. And they actually succeeded. They did published the malicious release. Fortunately, someone figured out what they were doing before it actually made it to their target. But the attack itself, like they did manage to successfully publish a malicious release. Hillel Wayne wrote this really detailed article called Stamping on Event Stream on his blog, hillelwayne.com. And he basically goes through all the reasons that this happened. And the short version is that this could absolutely happen again, because it's not like there was one thing that NPM could fix to prevent this. And it's like, yep, that will never happen again, which was the case with LeftPad. They just said, yeah, you can't publish packages anymore, so the LeftPad incident cannot repeat. Event Stream absolutely could repeat. I mean, there's a bunch of reasons why this was able to happen, and they're all still there. So here's a question. What's the difference between like getting my packages this way, where I want to install a package and I run bash install.sh and it executes whatever is in that sh file, versus running npm install? Well, one difference is that when I run bash on whatever this install.sh file is, I'm executing arbitrary code on my machine that somebody else wrote. And the difference between that and npm install is with npm install, I'm executing arbitrary code on my machine from thousands and thousands of packages. It's way, way worse, way less secure than running bash on install.sh. And this might come as news to you if you're not familiar with this one particular quirk of NPM, which is the post-install and pre-install hooks. So any NPM package can put this in their package.json. They say, hey, by the way, anytime anyone installs me, run this JS file that executes Node.js code, which is to say arbitrary code, that installs a virus on the user's computer. Anyone can do this. Any package you depend on and any package they depend on, every time you run npm install, you're executing every single one of their post-install hooks. That's just a thing that we all do. So NPM disclosed this vulnerability in 2016. They wrote a whole blog post about it. And I'll cut right to the chase. At the end of this blog post, they say, if you want to be not vulnerable to this, run this, npm config set ignore scripts true, and this will, by default, make it so that pre-install and post-install scripts do not run whenever you run npm install. I've had this configured for many years, well, since I read about it, and I can say like the ergonomics of this are not great. It does mess some things up, but I highly, highly recommend doing this anyway, because I really do think that this is going to happen now that there's sort of blood in the water. We're actually starting to see real malicious packages. This is not a hypothetical anymore. I think it's just a matter of time before someone decides to infect millions of developers' viruses. NPM is used by a ton of people, and that's, I think, going to be a juicy target for someone who's like, I would like a botnet. Also, other CI servers, why not? So if you take only one thing away from this talk, please, please, please go run this script. npm config set ignore scripts true, and hopefully if there is a virus outbreak, you will not be affected. Okay, so to sum up, like, do I think that there is going to be something that replaces NPM, like Entropic or something else? At the end of the day, I don't think so. I think NPM is going to continue to dominate the JS ecosystem for the foreseeable future. I think it's going to have some of these problems. I think it's going to have a virus outbreak. But at the end of the day, I think it's going to recover from them. Maybe there's going to be different infrastructure. Maybe NPM, the company, goes out of business and GitHub takes over. Maybe the CLI, because of this vulnerability, like people decide to use a more secure CLI with better defaults. I don't know, but I think NPM, the ecosystem, is going to persist. So prediction number 3, there will be more problems with NPM, but I think if anyone tells you NPM is going to go out of business, I personally don't believe it. Or at least NPM, the ecosystem, going out of business. Well, NPM, the company, no predictions on that. So by the end of 2020, I think there will be at least one more security incident that makes headlines. By the end of 2025, I think there will be at least one malicious NPM package that successfully infects a lot of developers' machines, except for all of you, because you've all run npm config set ignore scripts true, and you'll be totally protected from this. So again, please, we'll post the slides afterwards if you don't have that memorized, or just go read their blog post about it. Okay, and the final prediction, compile to JS. So back in the day, if you didn't want to use JavaScript, you were probably using one of two things, applets, which were really slow and kind of painful, or Flash, which was a thing until it wasn't a thing anymore. These days, though, there's a lot more compile to JS options. They kind of break down into two broad flavors. So one is sort of JS dialects. So these are languages that, in some cases, their tagline literally was, it's just JS. So CoffeeScript had this tagline. Typescript has this tagline. Dart is like extremely similar to JavaScript. Babel is literally JavaScript, like in a future spec ported to the present. Svelte is a JavaScript dialect that's focused on like making really small packages. All of these, like if you already know JavaScript, you basically can expect that this is not going to be terribly different from what you're used to. Which is to say it has the same upsides and the same downsides as JavaScript. They're going to be more ergonomic, maybe a little bit more reliable in various ways. That's not to say that they don't bring anything to the table, but it's just to say that if you're familiar with JavaScript, you're also going to be pretty familiar with the experience of using these things. In contrast, there are some others that are just basically straight up different programming languages. So the oldest of these is ClojureScript. So ClojureScript comes from the Clojure community, and basically it's like, if you like Clojure, this is Clojure in the browser. Another one is ReasonML. This is one of the more recent ones that came out of Facebook. The same people who made React came up with this idea, and this is basically OCaml, but with a JS-looking syntax compiled to the browser. And then, of course, Elm, which is my favorite. I work on the Elm Core Team. Well, I don't work. I work at NoRedInk, but I am on the Elm Core Team, and I'm a big fan of it. One of the reasons that people choose these languages is that it turns out they're kind of a cheat code for hiring good people. You might think that, oh, well, if you're using this less popular language, you're going to have a harder time hiring people. But I consistently hear that this is the opposite of reality. So just to give you one quote, we hired a head of talent, and she said, "I have never seen an inbound pipeline this strong. It's like this many people applying to a company." And the reason is just that we use Elm a lot, and we brag about it. We're like, hey, if you want to use Elm, like, come to NoRedInk. We have like 300,000 lines of Elm code in production. That's like, nobody writes JavaScript here. We all write Elm. It turns out there's a lot of people out there who are like, that sounds really nice. I would like to work there. And there's more people who want to use Elm than there are companies that have taken the plunge and actually committed to using it and are offering jobs in that. So if you do become one of those companies that is actually hiring for one of these less popular alternatives, as long as it's a technology people like if you're in the Perl boat where it's like, well, it's unpopular because everybody wants to get away from it, that's a different story. But if it's small because there's a lot of people who like it, but it just hasn't gotten mainstream adoption, then it actually turns out to be a really great thing for hiring. So some of the reasons that we like Elm, I mentioned, like, okay, it renders faster than the top JavaScript frameworks. It builds smaller bundles than the top JavaScript frameworks. Another graph is that I'm fond of is it almost never crashes in practice. So this is our error logs from production whenever like a runtime exception occurs. So this is like 60,000-ish on the JavaScript from like our legacy code. This is since we introduced Elm. The Elm one, it's not 0, but it is 0 pixels. Like if I were to zoom all the way in, okay, fine. Like it literally has happened. But it's so small that you can't actually see the number of times our Elm code has crashed on a graph. And keep in mind, this is like 300,000 lines of Elm code that's been running since 2015 in production. It's really, really reliable. Like in practice, you really don't see runtime exceptions. This is not something we think about anymore. It's just because the compiler is just that good at finding problems ahead of time before we deploy them. It also has a completely separate package ecosystem, which I really love. It's smaller than NPM. Like everything in the world is smaller than NPM, but like Elm package is much smaller. But it's really high quality. Like everything in the Elm package ecosystem is 100% Elm code. It doesn't actually permit you to do JavaScript interop with published packages, which means that all of these packages like follow all of the same guarantees that make Elm really nice for application development. Also, it means that like we don't have to worry about the NPM virus because it doesn't have that thing. There are no post-install scripts here. So all that stuff I said about NPM doesn't actually apply to us at work. But again, PSA because I know NPM is the most popular thing. So I'm aware of like the reality. Not everyone uses Elm. Another thing is the error messages. So this is from the most recent release, which was 2 Mondays ago. And this is now the error message you see if you get like a parsing error. So let's say you tried to use JavaScript syntax for importing stuff. Of course, Elm's a different programming language. It has a different import syntax. It says like, I was parsing and import until I got stuck here. I was expecting to see a module name next, like in these examples, and it gives a few different examples. And then it says, notice that the module names all start with a capital letter. That's required. And here's a link to learn more. So this is just one example that I picked. Like, could have picked a lot of examples. But like really, when something goes wrong, this is like the level of assistance we get from the compiler. It's really, really nice. It feels like you've got like an assistant helping you out. And I really appreciate that. I've never gotten that from any other language I've used. And really, like, I think this is the biggest thing, and I always kind of struggle to convey this without like actually, sitting down and being like, let's make some Elm code together. But just imagine if like in your life building web UIs, things normally worked. That's what it feels like to use Elm to me. Like, and I know this because I still maintain some like Node.js CLIs for Elm apps. And whenever I go back to that ecosystem, I'm always like, I installed this package and it broke. and like this, then I upgraded this one, and now this doesn't work anymore. What is going on? Like I'm used to like Elm land where I like install and upgrade packages, and like everything is just like works, or like once my code compiles, it normally just works. But here, like this is like all these things are breaking all the time. And I remember like I've been doing web development since like 2006. This is not like I forgot that happens. It's just that like I've been spending so much of my time the last few years using Elm that it's like kind of faded from memory. And so every time I'm reminded of that, I'm like, how do I convey to people like that it can be different? And this is what comes to mind. It's like if it sounds nice to have things normally work, maybe take a look at Elm. Okay, so at the end of the day, though, like I want to be clear that I do think TypeScript is what's going to take over the world. I think this trend is going to continue. I don't think that Elm is going to take over the world because at the end of the day, I think the JS dialects are just always what's going to have the most momentum in the web because JavaScript itself has so much momentum. It's kind of a monoculture. I think that Elm, ClojureScript, ReasonML, I think they're all going to remain pretty niche, but there's going to be a lot of happy people like me who are like, yeah, you know what? I still think this is going to age well. I'm going to continue happily using it. So prediction number 4, I think that these JS alternatives are going to stay niche and they're going to age well. Like if you bet on these like we did back in 2015, we are still thrilled with that decision. We have absolutely no interest in TypeScript because we're like, yeah, why would we downgrade to that from Elm? Like, but I know that not everyone thinks that. But those people I talk to who have made similar choices to use alternatives to JS, they're still happy with those choices. Like they don't feel like this is a Perl situation where they're like, oh, I can't believe I bought into this. They're like, no, yeah, this is still good. Like we know that everyone else is doing something else, but we're still happy. So I think by the end of 2020, I think they'll still be growing, but just not as fast as TypeScript. I don't think anything will be growing as fast as TypeScript. By the end of 2025, I think they will have aged well, although, of course, given the growth trajectories that I'm predicting, I think TypeScript will still be a lot more popular. And I'm fine with that. Okay, so to sum up, we talked about choosing boring technology and how this is really not a guarantee of success. You can very easily do like we did in 2006, pick something that's like the #1 biggest library ecosystem, most mature, used by successful companies, and yet still it turns out that people lose interest in it and you end up regretting that decision. So anytime we're making any kind of technology choice, we're just making a bet that we're still going to be happy with it 5, 10 years from now. If we're going to be making bets, it's better to predict than to just follow current trends blindly because those can lead us off a cliff. I made a few predictions about TypeScript, WebAssembly, packages, and compile-to-JS. I think TypeScript's going to take over the JS world. WebAssembly is not going to replace things, but rather it's going to expand the whole pie, like change the definition. I think NPM is going to continue to have problems, but at the end of the day, the ecosystem of NPM is going to survive those problems. And finally, I think the JS alternatives, like Elm and all the others, I think they'll stay niche, but people will still be happy that they made bets on them. They'll continue to age well as they already have. So what will I do personally? No, I think I've already answered that. I'm going to keep using Elm. And the reason for that is that basically, at the end of the day, if I'm predicting the future, I think it's going to age well. Thanks very much.